Thank you, Harry. Hello, everyone. So yes, I'm Arnaud. So I'm part of the Open Technology Group at IBM. I'm not an identity expert, actually. I'm an open source and open standards expert. And the reason I'm here today is because for the last 4 years almost now, I've been involved in Hyperledger, which develops open source technologies around blockchain for the enterprise. And one of the projects we have within Hyperledger is Hyperledger Indy, which is a software dedicated to self-sovereign identity, and that's what got me into this. I'm actually a member of the technical steering committee of Hyperledger, which oversees all the different projects, and I was actually recently elected as the chair of the steering committee. But so, let's talk about self-sovereign identity. And as Harry said, my presentation is pretty high level. I want to give you a sense of what it is. So if you already know, you're probably going to find this a bit boring, but hopefully not. And then Drummond will take you to the next level. So let's first start about the journey to self-sovereign identity. So we can distinguish kind of 4 different phases in the way identity has been managed over the years. And of course, the dates here are kind of fuzzy. Nobody really knows when it will end, any of those different systems. But first, we saw centralized system. This is the traditional system where you actually log into a particular system. Then we saw the appearance of federated system. This is something that everybody is familiar with. You actually use a user ID password that has been registered with a specific system, like Google or Facebook, typically, or LinkedIn is pretty popular nowadays also, where you actually use those identities to log on to other systems. It has the advantage of allowing you to leverage identity you already have. At the same time, you're sharing all the information with those systems. Then there are systems that are more user-centric. This system like OpenID, it actually has the advantage of putting you a little bit more in control, but yet you have to rely on the system that you don't fully control and is centralized. Your identity is in one place, and you can be tracked all over where you use that ID. So what we're talking about now is a system we refer to as self-sovereign identity, where we go to the next level, where you, the user, is in full control of your ID. That's what it's really all about, control. So there was actually a set of principles that were put together by NIST, one of the NIST working group in the US, about what it would take to have an ideal trusted digital identity framework. And so I'm not going to go through the whole list, you can read it there, but I think there are some important aspects that come into play when we talk about self-sovereign identity that are interesting to highlight. The first and foremost, again, is that the user is in full control. And the control is actually in different ways. We'll get more into this later. But one aspect is you want to control who has access to your identity and how much of your identity you should reveal every time you have to identify yourself. So the privacy aspect is very important. The traditional way is you log on, you create a user profile, and you're being asked all sorts of questions, which often are completely unrelated to the transaction you're actually having with the service you're connecting with. We want the system to be fully decentralized and trustable. And this should extend not just to individuals, but in a world where we have, everybody gets connected, even things. The system ideally should scale to identifying things as well as people and organizations, whether they're enterprise or not. It should be open and flexible, interoperable and portable, viable and sustainable. I'll skip to this. So, what's in this for the different constituencies out there? So first, from an individual point of view, the idea is to have a system that will allow, again, simplify transactions with the different services we interact with on a regular basis, and at the same time, keeping full control. And again, deciding what you consent to disclose in your transaction. From a business point of view, It's primarily about reducing cost, reducing risk. You know, it's a double-edged sword. Companies gather a lot of data, but we see news after news about data breaches where a lot of private information is being disclosed, has been hacked, and those companies are liable for those breaches, and it often is a very costly exercise. So there is also an interest for the companies to reduce their risk. And from a government point of view, they are actually interested in this because it increases protections for the individuals and it actually creates more transparency and reduces also counterfeiting, which is prevalent. So there are several use cases. I'll just highlight the first one, which is, you know, talks to a lot of people. There is this requirement about know your customer. And if you think about how it works today, companies all have to comply with the regulation associated with Know Your Customer. But it's a very expensive process, and it is repeated by every company out there, every service that you're transacting with. And so it's a bit silly because you could imagine a system that actually allows us to leverage the information that has been gathered by one company. And again, it shouldn't be done by the company on its own that stores this information in some kind of back-end storage, but it should be done in a way where the user is empowered with the information and they can be leveraged later on. So let's take a step back a little bit and talk about identity, because the way I started talking and the session is thinking about saying goodbye to Mr. Login. You might think what we're talking about identity here, we're simply talking about user ID and password. But identity is a much more complex thing than that. When you think about it, in your life, your identity is made of many different facets. You study, first you get born, you have an identity that's given to you through your parents and your government. But then over across your life, you're going to gather different facts related to your identity, which all constitute together your actual identity. And this includes, if you've been to university, you probably got a diploma from that university. If you got a driver's license, you have that part of your identity. If you're a pilot, you might get a pilot license, etc. You get a job, you're employed, that gives you some kind of credential, etc. So it's all of these things that really constitute your identity. And I have actually an interesting side story. I'm personally a dual citizen. I'm French and a US citizen. And I have had talks to government who said, no, we own your identity. And I was like, well, who owns my identity when I'm both French and American, right? And so it really shows that there is no single entity that owns your whole identity. Yet, all these different facets are not under my control today. To show that I have a university diploma, I still rely on the university I went to actually issue a piece of paper that proves that, and to be around to actually, assert that this is not a fake if I need to. So this is what we're talking about when it comes to identity in general. Now, let's look at the scenario about what it takes in a world of self-sovereign identity to prove your identity and deal with different facets of your identity. So we're talking about verifiable claims. So this scenario starts with this person who actually goes to university. Eventually they graduate. So in this case, the person becomes a doctor. At the end of the study, the university issues this claim that says, okay, now you're a doctor. They are going to actually send a digital credential of that fact to the user. At the same time, they're going to go to some network. In this case, it refers to sovereign, but there are many different options. They're going to store on this network enough information so that this claim that has been given to the user can be verified. independently. So now the person goes to a hospital looking for a job, and they have to prove that they are a doctor, they are qualified to get the job. So they can issue the credential that relates to the verifiable claims that was given to them by the university. And the hospital can then go to the network. So there's a pointer, and I'm not going to get into detail now, but there's a pointer to the network on which the keys to verify the information can be found. And the hospital can then verify that the claim is correct. What's interesting is this happens without ever contacting the university which issued the claim in the first place. And that's a key element to privacy, right? So you can actually do that as many times as you want, and the university doesn't come into play. And by the way, it also means that if the university was ever to go, it's okay, because as long as the keys, the network still run, the keys can be found there, the verification can still be done. So this model obviously scales to many different systems, many different types of claims, many different issuers. And so you get into these systems where you can keep building onto the verifiable claims you have accumulated. So in this case, now the person has a job, and they can get a claim from their employer that says, yeah, you work for us. That's one more claim that gets added to their wallet. And they can then go to a bank, for instance, to look for a loan, and they will use that claim. And obviously, you can combine those different claims as well. So not everything you're going to need comes from a single issuer. So the system actually allows you to combine different claims together. The other important aspect is that in this process, the user is going to be in control of what actually gets disclosed. So selective disclosure is a very important aspect of the model. What is written to the ledger? You know, I've been working on blockchain for 4 years now, close to 4 years, and I keep hearing people talk about blockchain as the perfect storage for secure data, because you encrypt the data and you put it on the chain and it's safe. This is horrible, because encryption only lasts about 10 years at best, and so it is absolutely fundamental to not write personal data on the ledger. What gets written on the ledger today in this model is actually just keys that are from the issuer. And they actually can be used to verify the claims of the user, but in and of itself doesn't contain any data that is specific to the user. You know, the analogy I give is that if you were to find those keys, it's a bit like finding a key on the sidewalk. And if you don't know what locks it belongs to, it doesn't do you any good, right? It's not the door. It's not the actual place you want to get in with that key. It's just the key. So that's a very important aspect. There are actually different types of data associated to the information that's stored, but it's primarily keys. There's this notion of decentralized identifier. There are also service endpoints that gives information on what to contact to be able to do the verification, and some hashes as well. What I want to highlight, and the reason I'm here, I'm an open source, open standards guy. The reason I'm here is really because what interests me in this is that for this to really scale, it only works if we have a system that is fully interoperable, where you don't depend on a particular system. Obviously, you can't expect all the different issuers to use the same proprietary system. You can't expect all the people, the verifiers, hospitals, banks, etc., to use any single proprietary system. So we have to have a very solid foundation which is fully open, which will allow full interoperability. And so there's a lot of different activities in both open source and open standards world, where we are focusing on standardizing the different aspects related to the scenario I just talked about. I won't get into the detail. I think Drummond might actually give you a bit more insight of this. But there are essentially 3 main standards. We actually attended, Drummond and I were last week in Japan at the first DID working group face-to-face meeting. And it was very well attended. There were 40 people in the room. And so this is part of the key of, it's a new type of identifier that allows you to find the information that you're looking for on the ledger, independently of which ledger you're actually working with. There is verifiable claims is essentially the format of the claim so that you know how to interpret the claim. And then there's a notion of decentralized key management because you're going to accumulate a lot of keys and you need to be able to manage those. And then there's a set of open source. As I mentioned before, I'm part of Hyperledger. We have actually no fewer than 3 different projects now that are related in Hyperledger. We started with the Indy, and then we actually spawned off different pieces of Indy. There's Ursa, is actually focusing on cryptographic. So it's more like a library. And the idea was we have different blockchain projects within Hyperledger. And everybody is reinventing the wheel, creating his own cryptography. And one thing that all the crypto experts will tell you is, please don't do that, because unless you're an expert, you're going to get it wrong. So we figured it's better to have one project that focuses on this, where some experts will actually create a library that is, usable by all the different projects. And then the last one is Aries, which is more like in the wallet space, trying to define a standard way of, or standard modules for the different projects to deal with identities. Because a lot of the Hyperledger blockchain frameworks that are in development there are permission blockchain. And so we all deal with identity. Verifying identity is a key part of those systems. And so there's a strong similarity here, obviously, and synergy. And so Hyperledger Aries basically is trying to define some kind of generic wallet mechanism so that they can be reused in the different projects. So I think I'm right on time. I kind of rushed, but I have one more slide just to tell you there is broad support, and this slide is by no means exhaustive. I threw a few, logos there. There are many other companies that are building on some of those systems, as I mentioned. So Sovereign Foundation as a network, IBM as an offering built on this. We're a steward of Sovereign, Evernym too. So there are many more names that could be thrown into this. I tried to reduce it to a few that are compelling to me and that actually provide some basic services like networks. So there are systems that are based on Bitcoin, there are systems that are based on Ethereum, and Sovereign is another network, etc. What that means really is, the importance of those standards, are fundamental to the success of this initiative. If we don't have a completely interoperable system to build on, it's just not going to work. So that's why we are doing this. To finish, I will give you one insight. I strongly recommend you, if you're new to this space and want to have a good grasp of what we're talking about, to actually go to the Sovereign Foundation website and look for the white paper. You read this, it's very well written, it's fairly high level, so you don't need to have a lot of background knowledge, and you will get a good sense of what this is about. And at the same time, it actually gets into quite a few details, technical details that might be of interest to you as well. So I will keep it at this for now. Thank you very much. I don't know if we have time for questions now, if we keep rolling and
we might have,
keep
actually.
the questions
you were so fast, so
yes.
Actually we're getting in both non-technical and a bit technical questions. I might pick some of those just to get it started.
I'm usually long, so I try to get fast, and now maybe too fast, sorry.
That one was an interesting one. How does retraction of credentials actually work.
Yeah, so there's a revocation mechanism, essentially. So, this was, and I'm part of the EU Blockchain Observatory Forum, and there was a whole discussion around GDPR and blockchain, with some people initially claim, well, GDPR pretty much kills blockchain. And it's just a ridiculous statement. And so this was fully discussed, and there is actually a very good report on GDPR and blockchain that I recommend you to look for from the EU Blockchain Observatory. But so one aspect that always comes up is, well, blockchain is immutable. You just can keep adding data to it, but you cannot remove it. And so people say, well, what about the right to be forgotten? If I put information on the ledger, I can never remove it. Well, that's one of the reasons you don't want to put personal data, first of all. And then the second part is there is actually a revocation mechanism so that when the verifier will check for the claim, they can also check that it has not been revoked. So the issuer, obviously, if you have a driver's license, you want your government should be able to say, well, we have suspended this license, so they expired, right? So those need to be able to be verified as well. And it's part of the verification process. It's actually a multi-step process that will actually allow you to find that out.
Okay, something else. There was a namespace question. How to avoid the fragmenting aspect of different solutions, platforms, or blockchains?
So this is an interesting question. And to be fair, we don't really know how this is going to play out. We actually had a discussion about that last week during the DID working group face-to-face meeting. If you look today, so the DID, which is this new type of URI that this whole system depends on, as a method name that basically gives you a way to sort between the different methods and the different network on which you're going to find the information, the record associated with that identifier. And when they started, they expected to have like a handful of methods. Turns out that they're already up to 30 or something like this, and we don't know where it's going to end. My personal view is I'm afraid it's going to explode, and maybe it will get better eventually, I don't know. But the system is, it's a bit like domain names. There is no real limit. The system can scale to any number of them. It may not be desirable, but as long as people actually leverages those standards that I refer to, there is no reason the system couldn't have thousands and thousands of methods and different networks. It may not be the best for the user because they are going to have so many fragmented identifiers, it may be harder to manage, but that's where DKMS might become even more crucial.
Okay, one more quick one, but this one is interesting. How does the decentralized identity relate to the identity issued by the state?
Well, so the identity by the state becomes just another verifiable claims. And I can tell you, I've talked to some government agencies that were very keen in playing into that. They see that as another type of service they can provide to their citizen, and they want to be an issuer. So essentially, it's just another piece of information that becomes part of your wallet. It might be one of the most important one, but it's just another one. So when you were born, you get born, instead of just having a birth certificate in the form of a paper, typically, you could have it in the form of verifiable claim issued by the state that would be added to your wallet so that you can then use that as you move on. Thank you.
Okay, there's lots of good questions coming in, but let's let Drummond
continue. We have a panel later, so yeah. I'm not going away.
We will go forward with those later.
Thank you.
All right.